And I will plug in the microphone. There we go. Okay. Okay, we have just finished a unit on exponents and polynomials, polynomial multiplying. So, based on what you know, this is a super easy example of it. What would you do if I showed you that on the last unit? You'd distribute. And what would you get? 4x minus 20, correct? Everyone agrees? 100%? Okay. How did you know it was 4x minus 20? Okay. How did you know it was multiplying? All right, because they bump right into each other, yes? So this is saying that you were taking this, which is a monomial, right? So that is a term, and you are multiplying it by this term, yes? Which means I have something times something, and I got an answer, yes? Now, that 4 then, since it is multiplying with something else, that 4 is a factor, yes? And it is multiplying by a second factor to give us a product. Does everyone agree? Everyone's happy with that? Okay. So what we have done here is expansion. That's what we did last unit. Okay? Everybody's happy with it? No problem, right? Everybody can do it. Now, what about this? What is the first factor in the second example here? No. X plus 4. That is the first factor because it's in brackets. So all of that is multiplying by this second factor, yes? And to get the product, what process do we use? You're all going to say FOIL, but it's really the distributive property, right? And what would we get?
X squared, X squared 6x plus 8.
Right? Is everybody cool? Everybody can expand, right? Okay. Now, think back. We've already done a bit of this year. When I said in the last unit, factor something, we did prime factors, yes? So you would have done in the last unit, which for us was unit 3? Right. In unit 3, when I said factor 12, we broke it down into 2 squared times 3. We did prime factors, yes? Okay. Now, this verb, factor, in math is always the same thing. You are always trying to break something down into factors. Now, what we did in Unit 3 was prime factors, 2 cubed times 3, right? And sometimes those numbers got big, and sometimes there were more than 2 of them, right? What we're looking for in this unit is pairs of factors. This will take you back more to when you were in grade 3 and grade 4 and you were first learning factor trees. The factors of 12 are all in this unit, the pairs of numbers that make up 12. Does everybody understand what I'm saying? So the first one for this unit, which is unit 4, when I say factor, I'm looking for just pairs. So it would be 1 and 12, yes? What is another set of factors? 2 and 6, and a third? 3 and 4. Can everybody understand these two differences? We're using the same words, and we are essentially doing the same math because we're dividing down something, right? But it's a different result, what we're looking at. Everybody cool? Now, you guys are smart kids. If I can break 12 into these pairs, and I can break, wait a moment, 12 times 1 is what? 12. 2 times 6 is 12, and 3 times 4 is 12, yes? These are the products, right? So I can break them down into 2 factors, yes? Now look what I've written in red up here. That's a product, right? And please notice it can be broken down into 2 factors. That's a product, yes? Please notice it can be broken down into, oh wait, I'm going to do something crazy. That's a product that can be broken down into 2 factors. Look what I did. Blue and yellow to make green. Huh? If this was America, I couldn't have made that joke. Because that's not teaching to the test. Hey, look, there's kids walking by. They look little.
Little kids, I love little kids.
Okay.
Were those grade 9s?
You should see my basement.
Huh? If it works for you, sister, let's say it does. All right, now, okay, once again, I'm going to do something that I'm not a huge fan of, but I'm going to do it anyway. Okay? Here I have a product, yes? Now, if I just had 6x, and I was falling into the trap of current math thinking that says it's not enough to be able to do math with numbers. And I asked you, how could you represent 6x? What are ways you could represent it? Well, in the 9th grade, we gave you a way. We gave you algebra tiles. But you could do a great many different ways to express that in pictures, couldn't you? How else could we do it? What else could you do to show me what 6x actually is? Because 6x written that way is not 6x, is it? That's just a symbol that is representing that. So how could you represent to me what 6x really looks like? Think on it for a moment and then talk to me. Go.
6 times x
Okay, so here are some things I have heard. I heard Sam say, well, couldn't you just write 6 x's? Does that show me what 6x really is? Yes. And in grade 9, we gave you algebra tiles, right? Yeah. We just gave you a different picture for what x is, right? Yeah. I could draw 6 of anything and say, as long as I say this is what x is, I'm in business, yes? Yeah. Okay. How could you draw 3? Now we're in trouble, aren't we? In grade 9, we gave you algebra tiles, the little square, yeah? What else could you do? You just said 3 dots. Is that okay? Yeah. Why? Because each dot is not an x, because this is 6 x's and this is 3, yeah? Okay. I think it was Armand just said, and I'm not saying you're wrong, I'm just writing something different because I need the space. Armand said you could write 3 1s. Right? 1, 2, 3. Everybody happy? Easy peasy, yeah? Okay. Now, since I have grouped them together into one solid thing, I know, because I have asked you to factor it, that can be broken down into 2 products. That's a single product, so I can break it down. I just said you can break it down into 2 products, didn't I? Yeah. You can break that product down into factors. And how would we do that? The same way we would do it with numbers, right? How can I break this up into pairs? I can have 3 groups of 2, or I can have 2 groups of 3. Everyone agree? Okay. How can I break this down? And I'm going to use the dots again. How can I break that down evenly? I can have 1 group of 3, or I can have 3 groups of 1. Correct? which one of those works for both of them? 3 groups, right? Because I have one group right there, and the circle didn't finish. Well, it's not a circle, to be fair. It's an ellipse. Yes, an ellipse.
So, Mars, I would just like to bring to your attention that this is what Taylor texted me when she's supposed to be having a fun time. What am I missing in math? Question mark, question mark, question mark. What are you guys doing right now? Kayla, help.
Give me your phone.
Kayla, help.
She's at the concert thing. The conference. Yeah. See, when I miss math, it's like Taylor texts me and she's like, you missed all this stuff. I'm like, yeah. And everyone's like, I don't even know. Great.
Mr. Marks, go scroll up and don't scroll down.
I have not scrolled up. I am not stupid.
What do you think Taylor and I would have in our conversation?
I was making Kayla uncomfortable.
Oh my gosh, Toby said yeah, pretty much. So like, Kayla, what should I just say to Toby? Like, what did he say?
Exactly what she just said.
Aww.
Now, okay, so you guys are smart kids. What do I have here? I have 2 X's and 1. And how many of them are there? 3. Now, you guys aren't stupid. Math guys would never write that, would they? What would they write instead? 3 times 2x plus 1, yes?
Oh, yeah.
Everybody cool?
Yeah.
That is what we call concretely. All right? Now, of course, yeah, what I should have said is said...
That's what 90% of your marks. She would have freaked out so
Yeah,
hard.
she would have left. She would have run out to the street and tried to hitchhike home. She would have been out there, big sign, Abbotsford or bust! And she'd come running in here at 2:25. I'm here! Can I have the test?
Okay,
right.
yes, I'm enjoying myself. Have fun, you guys. I'll watch the video.
We love you, Taylor. Everyone. There we go. Sam? Ah! All right. Everybody good? All right. So, now, you guys are smart kids, yes? Of course you are. What has actually happened here? What did I do to this giant drawing? I divided it into 3. Why did I choose 3?
It works.
Because 3 works with both terms.
Yeah.
Okay? So what I did essentially was this. 6x plus 3. I looked at that and I said to myself, self, both of those divide evenly by 3. So I ended up with 2x plus 1, but that's only a factor. I need the other factor, which is the 3, to get my 6x plus 3. Everybody's good, yes?
Yeah.
All right. So let's look at the next one. Turn the page over. It should say 4x plus 6x, yes? 4x squared. So now, how can I show this with a picture? Now, I could use algebra tiles, but I'm not going to. I'm trying to get away from algebra tiles if I possibly can. How can I show this as it actually is? What is that really? 4 times x squared, yes? So that's 1x squared, yes? How many times do I need to do it? 4 times. And then I need how many x's? Now, you guys are smart kids. I have two terms there, so I got to consider both of them. What are the ways I can divide up 4? 1 and 4, always, and then by 2, yes? All right. What are the ways I can divide up 6? 1 and 6, which we never care about because it's always 1 and 6. I can do thrice or twice. Which way works with both of them? Twice. Which means, what do I have here in that line? 2x squareds plus 3x's. What do I have in this line? 2x squared plus 3x's. A math guy would never write that, would he? He or she or they would write 2 times 2x squared plus 3x. And that would get them 4x squared plus 6x. Yeah? Does everyone agree? Okay, now. Is everybody comfortable with the numbers? Yeah? Okay, now we have to be smart here. What do you notice? There and there. They're both x's, right? What does x squared really mean? No, it means x down here and x over here, right? That is when algebra tiles comes in, right? And that square is that bar x times that bar x, right? Whereas this is just the bar, correct? What is common to both of them? Just the bar, right? So just the x. How many x's can this guy give away? 2. How many x's can this guy give away? 1. So how many x's can come out here? 1. Since this guy gave away 1, what's he got left? 1. And my computer's frozen, so what I'm trying to show you isn't working. Right. That guy's down to 1. And this guy gave away his x. So that's out there. Is everybody cool with the letters?
Yes.
All right. Now, use what educational theorists and psychologists call synthesis. You know what to do with the numbers. You know what to do with the letters. I've not told you what to do with both of them. You take the information you have and synthesize what to do with, don't do that, don't look at that, that's not for you, that's not for you.
What was that?
You take that information and synthesize what to do with this. Yeah. In a moment. In a couple of seconds, I'm going to give a 5 down to 0 countdown, in which time everybody will finish what they are writing and then bring their attention back to me, because that's what they do at teacher school now. 5, 4, 3, 2, 1, and now you're back. Attention to this.
I need more time.
All right, so Sam, what did you do here?
Okay, so I took out so the 5 first of all, I brought that out, and it left 3 in the second part, and then there was also in both.
So what do you mean you brought it out?
Like I divided it.
You divided it out because you were looking for the factors. When you have a product, to find factors, you must divide. All right. So you divided by 5. You get the numbers with the numbers. Then what?
And then in both, I divided it by x squared.
Why x squared? I only see x.
Because there's two x's in both sides.
Okay, so you brought out an x squared. Then what?
And then I did y squared because there's two x's, two y's on both sides.
Excellent. And what did you find out were your answers then?
It would be x minus 3y.
X minus 3y. Can everybody do it? Okay. This is step 1 of polynomial factoring. Now, if you can do that, you are in good shape. Turn the page over, and you should be looking at this page. All right. What we have been doing is GCF factoring. We've already talked about greatest common factor. Okay? And the way it works is this. You have a polynomial. Made up of a certain amount of terms. N terms. N meaning just some amount of polynomial. Yes? Could be a monomial, could be a binomial, could be a trinomial, could be any amount of terms. Yes? You start with that polynomial. And what you do is you recognize that polynomials are made up of coefficients. What's a coefficient? Right, so 3x, these things, the 3. And it's made up of variables, which are the letters, right? Those letters may or may not have what? An exponent. Variables, come along, wake up. I know you can do it. I know you want to. Variables could have exponents. And the last thing that they have, possibly, are constants. And constants are just numbers. Right? So what we are looking for when we are factoring is a single term. What do we call a single term? A monomial, which works in division with the entire polynomial. The L might show up and it might not. Okay? Is everybody cool? Yeah. Right now, we're just looking for a monomial. So, look at the first one I gave you there. Still waiting for the L to show up. There it is. Now, what do I have there? Mono, bi, tri, what? That's a binomial. Excellent. It has coefficients, variables, and a constant. So now I need to decide on a single monomial that works with all of those things. Okay? So, what is it? 5. Because 5 works with 5, x has nothing that works with it, and 5 works with 5. So what I do is I take that single monomial, which I'm going to highlight in purple, that is my GCF. And what I do is I take that GCF, which in this case is 5, and I divide all by that monomial. So I've done that here, right? Then I write the answer this way. GCF, which remember I've highlighted in pink, bracket, quotient 1 plus or minus quotient 2 plus or minus quotient 3, and so on. Quotient being the answer in a division question. So, over here, you guys told me that 5 works with both of them, yes? So how do I write this out? I put my GCF first, 5, and then I write all of my quotients. What's 5x divided by 5?
1.
No. X. Plus, what's 5 divided by 5? 1. And now I'm done. Okay? What is my GCF in number 2? 3. So I write it out. The GCF goes first, 3, and what are my quotients? 2x plus 1. Excellent. Now, things have changed in the third one. It's a trinomial, so now I have to consider 3 terms, and I have to consider exponents. So start with the numbers. Is there a number that works with 3, 12, and the constant? What is it? 3. Excellent. So everybody can divide by 3. Is there a variable that works with x, and So there is nothing there, is there? So what's my GCF? 3. So what do I write out front? 3, and then the quotients. X squared
Plus 4x
minus 2. Okay?
Okay.
And we already did this one with a picture. So let's just double check. Numbers, variables. What is the number that works with both? 2. Does the letter work with both? How many? Only 1, because this guy only has 1 to give. So what's my GCF? 2x. How do I write it out? You guys write it out because my computer's frozen.
2x bracket x plus 3. And then x. Yeah.
2x. And what's here?
2x plus 3. I said that.
All right? Everyone is good?
Yeah.
All right. Now, please see how I left a giant blank space over here, yes?
Yeah.
I don't care how you get this message to yourself, but get this message to yourself.
Always.
Simplify. Try to.
GCF and exclamation mark.
When?
Every time. Always.
When?
Always.
I don't think you understand me. When?
Always.
Every chance you have?
Always.
Whenever it works. Always try it. Are we going to get more complicated than this in a class that is right before IB math? Yeah. But are we going to forget that this is what we do first?
No, senor.
No. You guys do the next. You guys go up to and including page 157. 157. Now, there's 10 minutes left in class. That should be more than enough time to get that done and have no homework for the weekend. But just because I love you so much, we'll do the first one together. What's the number?
5.
5. What's the letters?
Just
X is in both, all 3. Anything else? No. So the GCF is 5x. So what goes out front? 5x. Then all the quotients go in the middle. 5y
plus 3x minus 6xy squared.
Now, guys, this is one of those things that I always forget to mention before we start. We call this greatest common factor, don't we? Right? But there is one exception to that rule. All right? We don't like negatives in here. Actually, I lie. We don't like negatives here. We want that to be positive. Okay? So look at C. We'll skip over B for now. Look at C. Right away, you should see what the GCF is. What is it? 5 CD, correct? But if I take out a 5 CD, what am I going to be left with inside? A negative. We don't like that. So we're going to take out the negative as well. And the reason we take out the negative as well will become apparent to you in a couple of days. But right now, if you can get a negative out, go ahead and take that negative out. Even though negative 5 is not the greatest common factor, is it? Because the greatest common factor is really 5.
That's
Right?
a really good analogy for life and stuff. You know? Take the negative out.
Okay.
Even though it might not be the greatest one.
All right.
Take it out.
So now, even though we call it GCF, what's really coming outside? Negative 5 CD, and what's staying inside? 4. Right? Plus 6.
C squared D plus 5. Bracket.
Everybody cool?
Read it just there.
Everybody good? Okay. You finish those basically 2 pages. And since one of them is just a quick reminder on how to polynomially multiply.
Don't.
Have a good weekend, Taylor.
Bye.
Have a good weekend, all of you. Now, wait. You have 2 pages of homework. It is page 156 and 157. It has now been mentioned in the video. Just in case you didn't hear the first 4 times I said it today in this video.
I love you, Taylor.
We all love Taylor. She is the spokesperson. I will tell you, Taylor, it took a long time to get anywhere today without spokesperson. I know, it's been very
There's
difficult.
nobody to debate everything that Mr. Meyer says. Oh, yeah, that's true. No, Sarah and Lauren are both the debaters.
But tell Byron to have a good weekend too.
Too late, I already pushed stop. Byron didn't send us any texts. Oh, he did though, he sent that Instagram picture, didn't he?
Snapchat story, yeah.
Too late.
Math group chat.
So it goes.
I don't have a math group chat.
He's snowboarding. He's laying in the snow.
I could just imagine him getting on the scale, off the scale, and wait, it's math starting right now. Gotta text him.
No, Byron wouldn't do that, but Taylor would.
Yeah, that's true.
I would too.
Yeah.
Bye.
Now Byron's feelings are going to be hurt.
Oh boy. It's not stopped.
No, it is stopped. No, it's stopped. Oh, wait a minute. It is still going. Oh, Byron, have a good weekend.